In this video, we're going to look at the difference between rounding and truncation and how that affects upper and lower bounds and error intervals. As you know, with rounding, you look at the next digit and round up if that digit is 5 or more. With truncation, we simply chop off what we don't need and add zeros to maintain place value. We can almost imagine a truncated value coming from a broken calculator display where we can't see the last digits on the display. So starting with 345.3456, if we rounded to one decimal place, we'd get 345.3. If we rounded to two significant figures, we would end up with 350. Truncating to two significant figures, however, we keep the first two significant figures, which are the 3 and the 4, and we don't round up, but we add the 0 to maintain place value, so we get 340. Rounding to 3 decimal places, we round up, so we end up with 345.346. However, truncating to 3 decimal places, we simply take the final 6 off the end. Truncating to 1 decimal place would give us 345.3. Let's look at how this changes the upper and lower bounds. If we had 5.4 truncated to 1 decimal place and we wanted to know what values it could have been, then again start with your number line, 5.4 in the middle, 5.3 and 5.5 at either end. Now instead this time of our upper and lower bounds being at the halfway points, the lowest number it could possibly have been is 5.4, because what we could have chopped off the end is a whole load of zeros. The highest possible number that we could have had is 5.49999999, but that's too unwieldy to work with, so we actually say the upper bound is 5.5. In an error interval, that would then give us that the number could have been anywhere between 5.4 and it could have equaled 5.4, that's why we have the equal sign on there, and the upper limit is 5.5. We don't have the equal sign on there because, strictly speaking, it's 5.499999. Okay, let's compare what happens finding an error interval with truncating to rounding. So let's start with truncating. So 24 has been truncated to the nearest whole number. So I'm going to start with my number line, 24 in the middle, it's the nearest whole number, so 23 and 25 on the ends. So I'm going to get, with truncation, I'm going to get a lower bound of 24, so the number itself, and an upper bound of 25. So lower bound of 24 and an upper bound of 25. So you can see my range of possible values is essentially the top half of my number line. So lower bound of 24, upper bound of 25, which gives us an error interval of y greater than or equal to 24, less than 25. So this example is on your note sheet, so if you've printed that off, then you can simply just fill that in. If you haven't, you can copy it into your notes book. Let's just compare this then if the number y was measured as 24 to the nearest whole number. So this strictly doesn't say rounding, but if it's something, it says something is measured, it means rounding. So again, with our number line, we would begin with our 24 in the middle, 23 and 25 on each end, and as we know, for rounding, our error interval stretches between the halfway point. Sorry, that should be 23.5 and 24.5. So this time my lower bound is 23.5, my upper bound is 24.5, and I can see that my error interval stretches between the halfway points. And there's our error interval there. Okay, what I would like you to do is just pause the video and have a go at this one. So first of all, truncating 3.6 to 1 decimal place, find the error interval, and then compare that to rounding 3.6 to 1 decimal place, find the error interval. So just pause the video and have a go at that, and then you can compare your answer. So there we have truncating the error intervals in the first half of the number line. Compare that to rounding. And we have the error interval between the two halfway points. The other thing that it's worth noticing, and we're just going to make a note of this in a minute, is when we truncate, the upper and lower bound have the same number of digits as my original number. Whereas when we round, because we're going from the halfway points, the upper and lower bound have one more digit than the original number. Okay, just make a note on some of these key differences between rounding and truncation. So rounding, the upper and lower bound has one more digit than the original number, and if the question says measured to, so let's just see if we can highlight that, measured to or to the nearest, it means rounded. In truncation, the upper and lower bounds have the same number of digits as the original number. Normally a question would explicitly specify truncated, but if it talks about a broken calculator display, that means you're working with truncated numbers. So just make a note of that, and then I would like you to spend 10 minutes on the error intervals times to challenge, paying particular attention to whether numbers are rounded or truncated.